What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. In this video, we will be looking at part 3 of our scientific and numeric computing tutorial series in Python programming language. In this video, guys, I should mention that you guys will find this one particularly interesting. The reason being, we will be looking at mostly practical elements in this video, right? So my goal for this video is to kind of give you an insight into a few of the many ways in which we can do array creation with NumPy package. Okay, so let's get to it. I will create another cell here. So as you guys can see, I still have the code from the previous, tutorial series. So what I'll do is at the end of this tutorial series for NumPy, I can provide you guys with the full script. Okay, so yeah, that will be useful for you. So let's get to it. I will import NumPy again, in this cell. So let's comment the code. Import the NumPy package as np. Now, guys, this portion deals with NumPy array creation. So the first and foremost way and simplest way in which we can create a NumPy array in Python, guys, is, as you know, right, Python supports a simple list or array. This is, kind of like the standard list or array object in Python, a simple square brackets. Okay, and I created a list. I set it equals to that. This is our standard Python list or array object in Python. I have the ability to populate this with elements of my choice. So create a standard Python, let's say array, because the data types of the elements are the same. Okay, so that's my standard Python array. Now, using NumPy package, I have the ability to access the np.array method. It's a built-in method provided to us by the NumPy package, and as you can see, the array function or method that is part of NumPy package takes in one object as the compulsory parameter. Okay, that object needs to be array-like, in other words sequential, sequence-like, and that's meaning and iterable. Okay, which is basically this list. So I have the ability to pass in any sequence-like object or iterable into the NumPy array function. Okay, and it will convert that sequence-like object or array-like object into a NumPy array. Okay, so I'm passing a list. Okay, now that's good. So let's do a comment. Utilize the np.array to create, or let's say to convert, an array-like object into a NumPy array. That's good. And now, just to show you guys, right, you are probably wondering, how do we know that I'm working with a NumPy array after I use the np.array method or function? So the way in which we can check is, let us check the types of the data types, rather, or the class to which a list and array objects belong. So if I hit enter now, as you guys can see, the first one we are working with is a list, which is basically the standard Python data structure that's provided to us. And the type of array object, as you can see, is numpy.ndArray. Okay, which means we've converted something that does not support broadcasting into a ND array that supports broadcasting. Okay, so that's interesting stuff there. Now, the next one I'd like to show you guys is what's called, we did cover this simple method in a previous video, all in all, it's called the NumPy.zeros function or method, and within this I pass a tuple, a tuple containing two values, comma separated. The first value is the number of rows I'd like in the array. The second value is the number of columns. So let's say I would like a 6 by 4. That tells me I'm going to have 24 elements, and by default the zeros function or method will populate your array with only zeros, all zeros. Okay, so let's do a utilize np.zeros to create an array comprising only zeros, pass the shape in the form of a tuple. Tuple takes two values, row and column, rows and columns. So if you think about it, guys, now that I think of it, the script that we will end up with after we've completed all the features and functions that I want to discuss in NumPy, this script is actually going to be a very good kind of cheat sheet for you, okay, for NumPy, because we are taking our time and we are doing things properly. So view the NumPy.zeros array. And as you guys can see, I have 24 elements. 6 by 4 is 24. All of these elements are 0. That's what the NumPy.zeros method does for us. Moving on, I'd like to introduce you guys to one that we've also seen before again. It's called the NumPy.Arrange. What I'd like to speak about is just a refresher, okay? Arrange requires one compulsory parameter, which is basically the stop value, okay, and that stop value is exclusive. So by default the arrange will generate from 0 up to the stop value excluding. So start is defaulted to 0, stop is the one you provide, and step is defaulted to 1. So let's do start is equals to 0. I'll do stop is equals to 100, and I'll do step is equals to 1. The step is defaulted to 1, and so is start. It's defaulted to 0. The reason why I listed the names of the parameters or provided the names of the parameters is so you understand the logic behind this function. So utilize the np.arrange function to generate an array from 0 up to the stop number, excluding np.arrange defaults to a step of 1. That's good. So all in all, I'm going to have an array including and containing the numbers 0 to 99. Okay, so print array dot, or let's just print array for now. View the array created by numpy.arrange, and as you guys can see, we do have this array containing 100 elements from 0 up to 99. 100 was excluded. Okay, so easy stuff for now. If you'd like to be even more kind of on par with the shape of your array, you can call a array.shape. So as you can see, it's 100 rows and 1 column. So that's what we have there. The next one I'd like to introduce you guys to is, still I'd like to mention one more thing about the arrange. So I don't want you getting confused. If you would like to have values generated from, let's say 10, start is equals to 10, stop is equals to 51, and step is equals to 2. I'm just giving you an idea, guys, of the step parameter and how it affects the behavior. So I'll comment these for now, and I'd like you guys to see this. It is nothing difficult. It is very similar to the built-in range function in Python. Okay, very similar. So let's say 10, 51, and 2, and it's basically a range object. If we iterate through that, we'd be having the same elements as this. The only difference is that this is basically an array creation, right? Gives us the values itself, not something that can be iterated standardly. Okay, so anyway, that's just kind of a comparison for you, right? For a range, you'd have to iterate. Okay, guys, so the next thing I'd like to introduce you to, the next, method or function is called the NumPy.Logspace. Array is equals to NumPy.Logspace. We have a few parameters that we work with. Start, stop, so I'll list them all out for you. Start is equals to, let's talk a bit about this, right? Now, the Logspace method, it will allow us to generate evenly spaced numbers using a log scale of our choice. Okay, by default the log scale starts at 10. Okay, it defaults to that value 10. Okay, so what I'd like to also tell you is that with regards to the NumPy log space function, so we have a start parameter, which is basically the start of the interval range. We have a stop parameter, which is basically the stop of the interval range, and we also have num, which basically is the number of elements that we would like to generate between the start and stop values. And base, as I mentioned, it defaults to 10, but we have the ability to change the base of that log to anything we like. Okay, so I'll give you a small demonstration, right? Suppose we would like to generate array containing values that range between 1 to 10, and we'd like 100 numbers in with a base of 10 to be present inside that array. So what we do is start is equals to 0, stop is equals to 1, we do a num is equals to 100, and base is equals to 10. As you can see in the code completion prompt that Spider offers, it says base is equals to 10.0 by default. So if I print this array out to the screen, I'll add a comment here first. Utilize the np.logspace function to generate an array from start value to stop value containing num elements in the base that is provided. Okay, so logs are at play here, guys. Log as in the mathematical log that we use, which is basically short for logarithm. So yeah, anyway, if I hit enter now, as you guys will see, my numbers range from 1 up to 10 because it is in the base of 10, and I have 100 elements here in my array. So I'll give you a small insight into that. Array.shape, which is basically 100 by 1, as we were expecting, 100 rows and 1 column. So that's basically a vector, right? Anyway, the next thing I'd like to show you guys is maybe we can talk about one more interesting thing, and I'll see if I'll probably end the video. I'd like to tell you about this interesting feature. So let's suppose what you'll find is that NumPy is very often used with image processing. I hope to create my own computer vision tutorial. So it is interesting, and all you must know there is that when processing images, NumPy is used heavily. NumPy is really helpful, and computer vision And with regards to image and video processing, it revolves around numbers, right? Because the computer breaks that image into numbers. So let's suppose we have an image that contains zeros in the shape of 5 by 5, right? So if we print image, you'll see it's a NumPy array that has 25 elements, and all of them are zeros because we use the zeros method or function. That's good. Now, suppose we want to basically create a 5 by 5 by 5 array. So 5 by 5 by 5. This is extra information, guys. So this is for, you individuals who understand a little more than the concept of just NumPy. You understand that this is basically basic Python syntax. Just as we work with a single 1D list, a 2D list, you get 3D, 4D, 5D as well. They can exist, right? Lists within lists. So this is based on that concept. Suppose we want to create a cube array that's 5 by 5 by 5, and we want it containing ones only. Now, this is for me to basically introduce you to, we are aware of this zeros function that exists, right? Specifically, we want an array that's 5, 5, and 5. That's good. That's sorted out. Now, NumPy there's it here, this as type method, which is basically a method that's used for kind of casting or converting arrays into a different type. Okay, so what we do here within this function or method is it allows us to copy an array, right? And we can cast it to a type that we like. Now I'll give you a little demonstration of that. So initially we have this NumPy.zeros. It's a 5 by 5 by 5 array. We used the .as type method on it, and we are passing in int as the type, and we are adding 1 to the contents of the array. The reason why this portion here works, it will convert all of our elements inside the zeros array to 1, because we are taking each element and we are adding 1 to it. So it all stems back down to the concept, which is very important, and we talked about it. It is called, I hope you guys remember this, broadcasting operation is very powerful in NumPy. So that's that. It all stems back down to the broadcasting operation. If you guys would like to, confirm, let's first go ahead, print image. There we have image, those zeros. Let's go ahead and print cube. And as you can see, a 3 by 3, a 5 by 5 by 5 array containing all ones. Okay, so if you guys would like to make this, simpler to read or to basically understand, we have the ability to create a 2 by 2 array, and we casting it as ones. If I take out this as type, my array is only going to have zeros. So super cool, right? I find this very, very interesting. So is there one more thing that I'd like to show you? Yes, there is. So you guys understand, right? NumPy has a zeros method, right? And believe it or not, NumPy in Python actually has a method called ones. And if you guessed it, it will create an array that contains only ones. So let's do a simple example. Suppose we would like to create an array cube. This array cube contains ones. And let's say my shape is, let's keep it simple, maybe 3 by 3 by 3. So I'd like to mention, I'm not forced to be, pushing y'all with 3-dimensional arrays, but I'm just trying to lay the foundations from now, trying to get you comfortable with just seeing what 3-dimensional arrays look like. I gave you a little insight in the previous tutorial, the way to tell the dimensions of an array. It's kind of like a trick. I'm not sure if it works all the time, but I know for a fact it does for me. All you have to do is count the number of brackets you see, at the end of the array or at the beginning of the array. So here, see 1, 2, and 3. That tells us it's a 3-dimensional array. This is a 2-dimensional array. So that's that. Alternatively, you can utilize the endim function, but don't stress about that. We'll have a look at that when the time comes. So I want to do myself a favor and I want to print this cube of ones. And as you can see, it is a 3-dimensional array containing ones. Okay, it's a cube. We call it cube to describe it. Anyway, the np.ones method will create for us an array containing ones in the form of the shape provided. That's good. That's easy to understand. Now, building on that, on this ones function or technique that we just used. Suppose we have our ones, right? Yes, we do. But now we have our ones in a sort of decimal form, as you can see, right? There is a point here. These are all points because they are decimal values. So what I'd like to introduce you to, I'm not going in depth here. All I would like to mention to you guys is that, guys, in Python, right, we know of data types that exist such as int, float, string, bool, and so on. But specifically focusing on NumPy is used mostly when we work with int and float, right? Because we are looking at NumPy in the perspective of scientific and numeric computing, okay? So numbers. Now the thing is, NumPy actually provides us with so many other types of data types. I wouldn't say other types, I would say other kind of what's the word, variations. That's the word. Other variations of data types. Like, I'll give you an example. Let's say we have an object cube. It's a numpy.ones array, maybe in the shape of 3 by 3 by 3, just as we've been working with earlier. Now I forgot my tuple. Yeah, so we take this and we can use the as type method on it, right? And we have the ability to specify within the type. Now this is a type that's built into NumPy. As you can see, I type np.float and I have more options here. A float 62, a float 16, a float 32, a float 64. Okay, there are more that exist, but for now I specifically just want to give you a little insight, right? 16-bit, we are using the number you see basically stands for bits, right? This is standard computation rules. So as you can see, 16-bit precision floating point number. So let's go ahead and utilize this. Print my cube. And as you guys can see, it is the same because we are not using kind of decimal points. But the point of this is just to make you aware that NumPy gives us access to different variations of integers and numbers that help us when we are doing precision calculations. Okay, now by default, when we use the NumPy package and its methods, when we are default using it as it is, it's good to know that NumPy will be making us work with 64-bit numbers. Okay, basically float 64. Right, as you saw, it is an option as well. So I'll type float, this one here, that's the one it defaults to, right? And the elements in our array default to a precision of 64 bits. And it does take quite a bit of memory in our computer. Memory is RAM, and it's not always necessary, especially if we're not working with numbers that are super large, right? So that's why now we have the ability to specify the depth or the precision of our numbers by setting the parameter inside the as type. And I don't know if you guys saw, but the parameter is d type, and that's what we utilize, right? So we have the ability to do numpy dot and whichever ones you like. So that is interesting, right? um that's about it there. The next thing I'd like to tell you, so before we actually wrap up on this, right, on, so this was a float 16, so we can say create numpy ones array utilizing 16-bit precision. Ah, did I spell that right? Yes, I did. So that's that. Now, building up on this, right, we have the ability to utilize any of the data types that we like to use in Python, along with those that are available from NumPy. So like array is equals to numpy dot zeros, and we can say maybe we want a shape is equals to 2. Yeah, I just pass 2. Then we can pass in a d type. This is given to us directly in the methods itself, guys. Notice we are not using the as type function here, or the method here. We are passing it directly as a parameter d type to zeros. So this is just me showing you that it is a possibility, right? So d type is equals to int print array, and as you guys see, this is the array here. So I'll comment this out for now. So there we have it here. It's an integer. Okay. Now if I say float, or let me copy that then. I want you guys to have the full script. So float. And here you see, this was the int. This is the float. We have a decimal that we see. There's the point. So that's interesting, as you guys can see. And maybe we would like to have, so let's say create an array of zeros with integer, or let's say using integer d type. D type stands for data type, guys. So here, create an array of zeros using float d type. That's that. One more I'd like to just push out to you guys. So create an array of zero using a 32-bit floating precision. So I'm sure by now you guys will be able to fully code this simple line of code by yourselves. So they're asking us to create an array of zeros using a 32-bit floating precision. There's two ways we can do it. We can use the as type, right? So just create a standard array, then as type it to float 32, or within this, as we just did here, right? So np.zeros shape, I'm just making it simple for us. Let's keep it 2 by 2, and then d type is equals to numpy dot float 32. And if I hit enter now, you'll see my array is printed for me. So I'm getting an error because I actually forgot the equals to sign there. Let's space this out there. Okay guys, so I hit enter and you see I have a zeros array 2 by 2 with a d type of float 32. Okay, so it is interesting, you guys. We're not seeing the kind of like the effect it's having on our array, because we are just working with an array of zeros and ones. So you guys can definitely feel free to explore, create arrays with floating point numbers, and experiment with these float 62 float 16, 32, and 64, and just tinker around with it. So that's fine. Okay guys, so with that guys, I'd like to end this video here. We've covered quite a bit of ways in which we can create arrays using the NumPy package, right? We've coded quite a bit of lines today. This is well over, I would say, 100 lines, including comments. So yeah, this is good guys. I'm happy with the progress we've made. So this is where I tell you thanks guys for watching. Thanks for staying till the end of the video. I appreciate your time. I hope you guys are learning well from this tutorial series. If there's any other tutorials or stuff in Python that you'd like to see, do make sure to leave a comment down below. Tell me and I'll look into it and try to come up with a small tutorial of my own. I really like teaching you guys these kinds of stuff. I mean, anything IT related, count me in. So thanks for your time guys. Good luck with your work and I will see you in the next YouTube video.